We next have Bo from Fleak talking about how you can actually use AI, which you've not heard of at all this morning, to actually benefit with OCSF.
Hello, guys. My name is Bole, and thanks for having me here. Oh, it's a big room and a lot of people. I'm kind of nervous. Oops. Sorry. Still work?
Yep.
Still working? Okay. Sorry about that. Yeah. So today I'm going to talk about some work we've been working on to use AI to normalize different log data into OCSF format. So some quick background on myself. I'm the co-founder and the CTO of Fleak. We started about 1 year ago, and I spent multiple years at Splunk, at Netflix, and mainly focusing on building a large-scale real-time data processing engines. Yeah, so let's start from the problems. Well, you guys all know the problems. We got enterprises use so many SOC vendors and like security tools and so many different data formats and stored here and there, and then it's a nightmare for SOC analysts to like really do some investigation, or if they want to write some detection rules, that's really hard, right? And of course, cost is going up for companies. And for that reason, we have OCSF. We want to standardize things, right? The purpose for OCSF is to transform different, to normalize different logs into the same standard so that they can be stored together, and so that they can be stored together, and we can write the same detection rules to do detections, to run the analytics, and it's much more efficient. But as OCSF is growing and it's becoming, trying to cover more and more different use cases, it's also becoming a bit complex. And people are trying to map their data into OCSF, and this process can be also tedious, right? Our interview show, we have conducted the interviews with different companies, and it shows to us that people are still doing it manually, which takes days, weeks to map different data formats into OCSF, and that's really tedious and time-consuming. But however, as you guys will see for the first time probably, AI. So we have AI, and we are able to use AI to. Then we were thinking, why can't we just use AI to make it do faster? And that's our solution. We are trying to use AI to make this mapping be more efficient and automate this mapping so that we can reduce human effort. So here's our solution. In the middle, there's a brain. That's the AI, right? And so we are. You can think of it as something that translates your data from all different shapes into a common OCSF format. Right? And the next part will be a little bit nerdy, but yeah, so here's our architecture. Actually, there's one thing missing in this picture. Our solution contains 3 pillars. The first one is the mapping language. We are developing a mapping language that allows people to express their transformation logic, right? And then comes to the AI part. This the top of the box, the AI part, where people can we use AI to help people to automatically generate this mapping translation. That is different from manually. Of course, you can manually write it, but using AI, it makes it becoming much more faster. And also, we have the human in the loop. You cannot always expect the AI to be 100% accurate, right? So we also have human. We also allow human to adjust the AI generated mapping rules. And once it's done, the third part is the execution engine. 2 weeks ago, we open sourced our core execution, which is Zflow. It's a lightweight Java data processing engine that allows people to transform their logs at real time. And the mapping rule generated by the AI can be simply passed to the Zflow, and which starts the execution. We also did some preliminary benchmark about our AI accuracy. So the benchmark was done against the open OCSF GitHub examples repo and in a markdown folder. And we looked at the required fields only. And the AI was using, we were using a Cloud Sonnet 3.7. And this benchmark was purely done manually, and so it's a pretty preliminary, but we can see that we roughly can achieve about above 90% accuracy, which is pretty good. But of course, you have to know that OCSF mapping sometimes can be subjective, right? For the same log, and for different use cases, you may map them into different OCSF events, right? But I think 90% is roughly okay, right? About that flow, so 2 weeks ago we open sourced this execution engine. We also announced it in the Slack channel, and that is a lightweight real-time data processing engine comparing to Apache Flink. Well, I've been working with Flink for so many years, so I know the pain point. And so with this engine, you can easily take this mapping rule and start to process their logs and transform it into OCSF. Well, here's the demo time. It's going to be some nerdy demo, but I think I need to switch to my laptop.
Sure.
So yeah, let's just, sorry, bear with it. Users come to the UI and they create a project. They started to provide some sample data. Okay, then they copy the log spec into the UI, which is not showing. And then you start to configure your parser to parse your text log into a JSON format. And here, this is some parsing, like you need to look at the syslog header. You parse the syslog header, and then use a grok to provide some grok to parse it into JSON. Okay, now you have JSON. And then you will hit the black button at the bottom to start the AI process. The AI process it has 2 phases. The first phase is to suggest the OCSF class for you. And once you select the class, it's going to start this mapping process. So yeah, so you select the class, then the mapping process starts, and it generates the mapping rule for you. And this mapping rule here, what you are seeing is the mapping language that we provide. And you can view the mapping result for your sample logs. And you can also cycle through. In this example, I uploaded 3 logs, and you can cycle through the logs. And you can also use the editor to edit the mapping rules, because AI may not be correct all the time. Maybe you also need to use some human to adjust the mapping rules. Okay, and there's this advanced mode where you can directly write the code, update the mapping rule in the code editor. And once you are ready, you are able to oh, by the way, the AI also shows you the explanation of the mapping, like why it maps this field, assign this value to the field, like shows you the mapping, shows you the explanation. This is the mapping language that we have. Once you have this, you can port it to the Zflow to execute. This is the example that I prepared. It will be a little bit nerdy here. So this is the Zflow code. We create a Zflow flow object, and then we attach the to back up, for this example, I prepared a bunch of Cisco ASA data, which has different event code. And the task is to translate all those events into OCSF. So using that flow, we first read it into from a file, read it from file, and you can see all the events got transformed, put into this field, underscore raw field. And then we start to add a parser config, which we just downloaded from the mapping rule. So this is to parse the header of the Cisco ASA data. So if you look at it here, if we put it into the JSON editor, you will see that the header fields of the Cisco ASA data got parsed. And at this point, we know that the message number of the event. And as you see in the input data, there are so many different message numbers, and we need to do some branching like this. We need to do some branching, like based on different message code, we need to do some specific parsing and then translate. So here, I'm just going to show you guys an example of the branching. Yeah. So now we are saying that, oh, I want to select only events with the 106.023 message, and then I add the parser part to parse the message body of the events. And at this point, after this, we print it, and we can see the message is fully parsed based on the message code. If we go to the we see the Cisco ASA data is fully parsed. And lastly, we'll just start with pasting the mapping rules. Okay, so this big text here is downloaded from the mapping app, right? We put it here, and then we process it. Now we get the fully parsed OCSF data. Okay, and the same thing for all different other message code. We allow branching in that flow. So as you can see here, we have different branches for different message code. And finally, we merge them into one flow and then attach a standard out sync. And if I print it, we got all the OCSF messages converted. And here, I'm just printing it out using a standard out, but we can also attach it to some Kafka sync or some different S3 sync to write into destinations. Yeah, so this is pretty much my demo, and I have just a couple slides at the end. Be part of the OCSF movement. Actually, I want to save the time for this slides. So we open sourced our engine, and this mapping tool that we just announced the public availability yesterday. So it's for free. Just play with it, try it, and let us know your feedback. And if you have sample logs that you want to create template, let us know. If you want to be part of a template creator, also let us know. I think together, if we contribute together, we can make this community more popular and having more adoptions. Yeah, and by the way, we have a booth today in the RSA, ESE65. Okay, thank you. That's my demo. Sorry about these technical difficulties.